All right, let's dive right into this explainer and completely flip the script on humanity's second home. For decades, right, the whole conversation about living among the stars has been totally dominated by one rusty red neighbor, Mars. Terraforming it, building bases, sending billionaires there, you know the drill. But what if I told you we've literally been looking in the wrong direction this entire time? Today, we're unpacking the ultimate interplanetary real estate pitch, and I'm going to show you exactly why Saturn's massive moon, Titan, might actually be the absolute best choice for a self-sufficient human colony. So here's the massive elephant in the room with Mars that almost everyone glosses over. It practically has no protective magnetic field. Our sun is constantly blasting out deadly cosmic radiation. And without a magnetic field to deflect it or a thick atmosphere to soak it up, the surface of Mars is basically a giant radiation zone. Meaning, if you moved there, you wouldn't be strolling down the street of some cool domed city. No, deadly cosmic radiation would force you to live out your days hiding in an underground bunker. Honestly, would you travel millions of miles through the dark void of space just to live permanently in a tunnel? Probably not. Now, when you stack them up side by side, Titan emerges as vastly superior. Mars has incredibly thin air and gravity at just 0.38 bars, but Titan? It boasts this thick 98% nitrogen atmosphere that actually provides a super comfortable air pressure, about 1.5 times what we feel on Earth. It's kind of like the pressure you'd feel diving just 5 meters into a swimming pool. And because of that dense atmosphere, plus the fact that Titan spends most of its time safely tucked inside Saturn's massive magnetic field, you are completely shielded from cosmic radiation. You could literally walk around on the surface without needing a pressurized spacesuit. How wild is that? And the sheer alien beauty you'd experience there every single day, it's just staggering. So Titan is tidally locked to Saturn with a 16-day orbit, and it gets 100 times less solar energy than Earth. Walking outside in your heated suit, you'd be bathed in this perpetual, faint orange twilight. The thick atmosphere scatters the light so it constantly looks like a hazy afternoon right after a wildfire. And because its tilt is similar to Saturn's, you still get distinct seasons, except each one lasts for 7 Earth years. Oh, and the rain? Imagine drops of liquid methane 50% larger than our rain, just falling in magnificent slow motion because of the low gravity. Okay, full disclosure, it is a bit of a fixer-upper. Because Titan is so incredibly far from the sun, the surface temperature is a blistering minus 179 degrees Celsius. I mean, it is unfathomably cold. It's so cold that the liquid flowing in those rivers and lakes isn't water, it's liquid methane and ethane. What about actual water? Well, it's completely frozen solid. Actually, the water ice on Titan's surface is as hard as granite. It literally forms the very bedrock and mountains of this bizarre world. But despite that deep freeze, the landscape is incredibly dynamic, and it's all thanks to this fascinating process called sintering. On Earth, our dunes are made of hard silicate sand, but on Titan, the sand is actually solid hydrocarbon dust that rains down from the sky. Normally, these weak grains should just get smashed apart by the wind, but through sintering, neighboring grains actually smash together and fuse into larger, stronger pieces. It's like a giant puzzle coming together on its own. This bizarre process allows solid hydrocarbon dust to form towering sand dunes hundreds of miles long, covering up to 13% of the whole moon. All right, now let's talk about how this all builds into literally the coolest commute ever. Because of Titan's incredibly thick air and low surface gravity, which is just 14% of Earth's, human flight isn't just a sci-fi dream. It's basic physics. You could simply strap on a specialized wingsuit, step outside, and just fly under your own muscle power. And if you're worried about falling, you don't need to be. The terminal velocity there is incredibly low. If you fall from any height, that thick air resistance means you won't hit the ground any faster than about 18 kilometers per hour. So how in the world do we actually pull this off? Well, to build a colony, we'd first send a fleet of smart robots to prep the groundwork. Titan has hundreds of times more natural gas than all the known reserves on Earth, so these robots would just convert the endless lakes of liquid methane and ethane into space-age plastic building materials. We're talking massive, insulated plastic domes. To power it all, we'd need highly efficient solar panels, though they'd have to cover about 10% of the surface because of the dim light, or we'd use advanced nuclear reactors. And inside the domes, we'd feed ourselves with lab-grown meat from massive bioreactors and, get this, highly energy-efficient cricket sandwiches. And hey, if you're worried about someone stealing your cricket sandwich, don't be. Committing a crime on Titan is practically impossible. The environment itself enforces the rules. To survive, colonists would be integrated into a highly monitored life support grid.
You're talking 24/7 monitoring by GPS, airlock opening and closing logs, and even biometric suits tracking your vital signs and adrenaline levels. If anything goes down, the data trail instantly points right to the culprit. Nowhere to hide. Okay, let's pivot and dive into the bizarre astrobiology of Titan because this place is far from a dead rock. Scientists actually view it as a deep freeze replica of early Earth. It's got incredibly active liquid dynamics, including erupting lakes. Yeah, you heard that right. Changes in temperature can cause nitrogen bubbles to explosively erupt from the methane lakes, carving out river deltas. But the real treasure? That might be hidden underground. About 50 miles below that granite-hard ice crust lies a massive subsurface ocean of liquid water, potentially harboring the chemical energy and exact conditions needed for actual life. But what if life is hanging out right on the surface in those frigid methane lakes? Earth-like cells rely on a dual-layer membrane that absolutely needs water to function, so they'd be toast in nonpolar methane. Any alien life here would have to be fundamentally totally different. Computer models and lab tests suggest these creatures would probably rely on a compound called acrylonile to form flexible, inside-out cell membranes. And here's the kicker. The Cassini mission actually detected traces of this exact compound in Titan's atmosphere. The building blocks for weird, methane-based alien life are literally already floating around up there. Now, speaking of the word Titan, let's take a quick, admittedly terrifying narrative detour. What if, instead of us colonizing a moon called Titan, we stayed right here on Earth and faced an invasion of literal, giant monster titans? Just imagine human-like creatures, as tall as the Empire State Building, suddenly washing ashore on every major continent, destroying everything with these massive strides. How would humanity even begin to survive something like that? Well, underground bunkers definitely wouldn't save you. These giants could just feel the vibrations of your movement through the Earth. According to this hypothetical survival guide, you need to aggressively scrub yourself with oil and detergent to mask your scent from their insanely acute smell. You couldn't just shoot them either. You'd have to repel them using incredibly high-frequency loudspeakers that target their sensitive hearing. And honestly, your only real long-term hope would be to evacuate on a massive ship to a remote, deserted island. Because despite their massive size, these titans are apparently terrible swimmers. All right, snapping back to the reality of space travel, the biggest hurdle for our interplanetary real estate pitch isn't literal giants roaming the landscape. It's the sheer mind-numbing logistics of actually getting there. The location might be chemically and atmospherically perfect for a long-term colony, but the commute? The commute is an absolute nightmare. We are talking about a journey that requires technological leaps we just haven't mastered yet. So the real deal breaker here is distance. Mars is relatively close, about 0.52 astronomical units away, meaning we can get there in a matter of months. But Titan? Titan sits deep, deep in the outer solar system. It is an agonizing 1.2 billion kilometers away. That's roughly 8.5 astronomical units from Earth. Traveling there with our current chemical rockets wouldn't take months. It would take several years. Any colonizing spacecraft would need to be massively self-sufficient, hauling enough life support, food, and fuel for just an incredibly long duration. And, of course, that immense distance translates directly into astronomical costs. Getting a heavy, crude payload safely all the way out to the Saturnian system requires vastly more fuel, way more complex life support, and so much time. This drives the estimated colonization cost to a whopping $400 billion. Compare that to the estimated $100 billion it would take to put a flag and a base on Mars within the next couple of decades. So for space agencies and billionaires looking for a quicker return on investment, Mars is the cheaper, closer gamble, even if the long-term living conditions are, frankly, vastly inferior. But here's the good news. We are already taking the very first steps to unlock Titan's secrets. With space agencies predicting a shift in colonization focus away from Mars around 2026, our robotic emissaries are gearing up right now as we speak. NASA's groundbreaking Dragonfly mission, which is this wild robotic nuclear-powered dual quadcopter, is scheduled to launch in June 2027. After a very long journey, it'll arrive on Titan's surface by 2034. It's literally going to fly from dune to dune, searching for water, analyzing the hydrocarbon chemistry, and hunting for the very building blocks of life. So as we look to the future of humanity among the stars and really weigh the harsh realities of our solar system, you've got to ask yourself a pretty important question. When the time finally comes to leave Earth, wouldn't you rather brave the frigid, slow-motion methane rains for the ultimate freedom to fly under a hazy orange sky, rather than live permanently trapped in an underground radiation bunker on Mars? It's a huge choice, and it might just define the entire future of the human race.